All right, so we're going to talk about section 10.4, which is perimeters and areas of similar figures, and we did a short investigation looking at how these work when we double, triple, quadruple things. But basically, if we have a similarity ratio, so between two figures, then we look at the perimeters and we look at their areas, and we can start to see a difference here. If our ratio, let's say, is 2 to 1, so it's twice as big, the perimeter is the same, but the areas go up by this square factor, and we'll see why that is in a second. So if we just start with one square unit that has an area of 1, and if I want to double that, well, that might think that that's doubling, but that's obviously not a square, right? I have to add 4 of them, and that actually doubles the side. So now instead of having a side length of 1, it has a side length of 2. So I've doubled the figure, and we can see right off the bat that the perimeter here is 1, 2, 3, 4. The perimeter here is 2, 4, 6, 8. So it's just doubled the perimeter. So it's the same ratio. 8 to 4 is the same as 2 to 1. However, the areas are different, right? This has an area of 1. An area of 1. This has an area of 4 square units. So we don't go by the same doubling factor. We square that value. So again, if we were to look at this, my perimeter is 4x, my area is x squared. On my other one, the perimeter is 8x, and the area is 4x squared. And if I take those ratios, the x's are going to actually drop out, and I'll see that I have really a factor of 4 and a factor of 2. And so this, if I was to make it 3 to 1, I would have a 3 over 1 squared is a factor of 9. It'd be 9 times bigger in the area, but the perimeter would be the same. It would be a factor of 3. So let's look at some quick examples from the classwork. So I'm given similar polygons and a ratio of 3 to 8. That's what I need. The ratio of their perimeters is the same, so it's just going to be 3 to 8. The ratio of their areas is I square that value, and I'm going to get 9 over 64. That's it. So that first one is relatively straightforward if I use my properties we just talked on the other page. All right. These are similar triangles. Find the perimeter of the larger area. Well, I need to first off figure out what my ratio is. So if I take the corresponding side, so 6 corresponds to 10, that means that 10 over 6 is my ratio. So this top one is 5/3 the size of the bottom one. And so I can do that for all the other sides. I can figure out what 4 corresponds to and 3 corresponds to by looking at how the perimeters match up. The perimeters got the same ratio. So that perimeter is 13. I'm going to take that and multiply it by my similarity ratio, and that gives me my value for the perimeter of the new one. So I should get a mixed number like that. All right. The next one I'm given corresponds to a regular octagon. Again, I've been given the ratio is 8 over 3. The area of the larger octagon is 320 feet squared. Find the area of the smaller one. Now, this is where I have to be a little careful because the area doesn't go up by, it's not just going to be 8/3. The area one, if I was to flip it in small to large, area small is 3/8 times 320 square feet, but that ratio is going to get squared, right? Because that's how the factor goes up. So it's not 3/8 times 320 square feet, but it is 9/64 times 320 square feet. Okay. If we look at the next ones, we have some rectangular fields. All right, we're talking about seeding them, and we need to think about, are we looking at the area or the perimeter? Well, I want to figure out the area because I put seed over the area, not just around the edges. That's where the fence would be. But I can set these up, and I have my values, my 2 rectangles, and I know that one is 3.5 times bigger than the others, and on both dimensions. And that's going to be able to give me how the area is going to be. The area is going to be figured out. The ratio is 3/5, okay, and it's squared because I'm talking about an area problem. So I'm going to take that ratio and I'm going to multiply it by my value for 8. So I get $30 if I was to square it. Actually, I had to go back and check the math on that one, and so I'm actually going to get $98. So that is 3.5 squared times 8. I just had a miscalculation when I plugged it in. So $98 will be that difference. And again, we want to think about the area is not linear. Just if I do 3.5 times 8, that's not going to give me the correct answer with that. All right. Now I have 2 similar pentagons. I have the ratio of the areas. What's the similarity ratio? Well, this is going to equal, if I was to simplify it, 36 over 16, that is 9/4. That is something squared. So I got to think about what ratio squared gives me that value. Well, it's a over b squared. If I take the square root of everything, I get 3/2, and that becomes my similarity ratio for that piece. All right. So again, keep in mind that perimeter goes up by the exact same similarity ratio, but area gets squared for those values.